So we're comparing the sine of 85 degrees and the cosine of 85 degrees. You need to know their definitions. I think by now you know that this is opposite to hypotenuse, and this is adjacent to hypotenuse. So 85 degrees is a tall angle. Therefore, you're going to get a tall triangle here with a short base. You're comparing this side to this side with this side to this side. Since the hypotenuse is the same in both cases, you can ignore it and just focus on opposite versus adjacent. Which one's larger, opposite or adjacent? Opposite. Three dots means therefore. It's also what the predator shines on you before he's about to shoot you. Therefore, opposite over hypotenuse is greater than adjacent over hypotenuse, which means that sine will be greater than cosine. And if you look at the statement, then it would be false. Okay? So we want you to think about these things. Anyone can plug in numbers into a calculator or ask Siri for the sine of 85. Big whoop. Next, number 21. Now we're comparing 44 and 26 degrees. So you can again think of the hypotenuse as being constant. We're comparing sine of 44 degrees and sine of 26 degrees. And since I've demonstrated one, I'll now call on you. Darian. So, which one do you think is going to be larger? Sine of 44 or sine of 26? And why? It's a bigger number and they're both sine? Yeah, I would probably want a little bit more from you just to be able to distinguish, that you had complete understanding. Like, for example, that sine is opposite over hypotenuse. The opposite to 44 is going to be greater than the opposite to 26. It's like a taller triangle, or it is a taller triangle than this one. So opposite of 44 degrees will be greater than opposite of 26 degrees. Therefore, sine of 44 degrees will be greater than sine of 26 degrees. Also, the hypotenuse is constant, or considered constant. Yep. So this would be true. Any questions on 21? Yes?
If it's the same, like same cosine, like if they're both like sine, is the one with the bigger angle always going to be bigger?
No. You have to think about it and you have to establish which ratio it is. So we had that come up in period 5. Somebody said, just look for the bigger angle, and that's not necessarily the case. For example, cosine if you looked at the cosine of 44 degrees and the cosine of 26 degrees. Again, sketch the triangles. 44 is going to be taller than 26. I tried to make the hypotenuse the same, just to keep it simpler. Cosine, you know, is adjacent over hypotenuse. So in which situation is adjacent going to be larger, 44 or 26? Anyone? Yeah. In the 26 degree case, adjacent is larger. So the cosine of 26 degrees is larger than the cosine of 44 degrees. Okay, so that's a case where it violates the rule that you, I think, were proposing. Last one there, 22. Sam. First I'm going to start with sketching the triangles. 41 degrees, 26 degrees. And tell me what you know about tangent, Sam. Good. So we have to figure out in which case will that ratio of opposite to adjacent be larger. Which triangle? The 41 degree one or the 26 degree one? The 41 degree one, yep. How do you know that? Well, Sam, maybe you can answer that. Okay. Okay. Can anyone explain it? Yeah.
Because the tangent, like for 41 degrees, it's tangent, the opposite would be adjacent in a way that.
Okay. Can anyone explain it? Yeah.
Well, because it's a right triangle, you know, one of the angles is 90.
Yep.
And the one we're looking at is 41.
Yep.
So 41 degrees has a direct correlation to the opposite side.
Yes.
So if the tangent, since it's opposite over adjacent, you're going to know the opposite is larger than the adjacent with this because depending on the angle, yeah, because the angles correspond to the opposite side. That's just, in my mind, that's how I figure it out.
Because the 41 is larger.
Yeah.
41 is larger than 26. Therefore, in a right triangle,
Therefore, the opposite side is larger.
therefore the opposite side has to be larger.
It's just like the one before.
Yeah, it's just it's a wider type of thing.
So it's like 20.
So the only way we can know is if we look at a picture.
Well, I wouldn't say that's the only way. That's what I would do. Somebody in period 5 said or suggested that I teach it with actual, like, tools. So I'll try that with you. Sometimes the old-fashioned ways are the best. So back before calculators and computers, this is how people did trigonometry. Protractor, ruler. Okay. First, I will create a triangle that has a 41-degree angle in it, a right triangle. Give myself plenty of room. (41 degrees). And if in class or on a test you want a protractor and a ruler, just ask. I have them. Again, this is a right triangle. I'm interested in tangent. So that's the opposite to the adjacent. It looks like my opposite side, and I really don't care about precision here. I'm just going to call it 5. And my adjacent side is like 6. Therefore, this thing we call tangent, I expect it to be about 5 to 6. Let's look what it really is. Okay, it's really 0.87. Like I said, I don't care about precision right now. I just care about conceptual understanding. Now let's do 26 degrees. Again, tangent, opposite over adjacent. I'm going to go with 3.5 for the opposite. And like 7 for the adjacent. Well, that's an easy fraction. So I expect the tan of 26 degrees to be about a half, 3.5 to 7. Let's confirm that. Yep, 0.49. So you can see here that for the 41 degree situation, the ratio is larger. It's 5 to 6, which is about 0.83. Here for the 26 degree situation, look, the opposite side is smaller than it is for the 41 degree situation. And when you do opposite to adjacent, it's going to be smaller than in this opposite to adjacent case. The taller this angle becomes, the taller the opposite side becomes, and the shorter the adjacent side becomes. And I encourage you to play with these tools. Okay, so this is like 0.5. 0.5 is definitely less than 0.83. Okay. So that's another way to explain it, yeah.
I'm just confused how we're supposed to be able to do that without using those things. Like, I just don't understand how you could just, like, eyeball it.
It requires some reasoning if you're going to do it without the tools. And it's related to what James said, I would say. You need to know that in a right triangle, the side opposite a larger angle is going to be larger. Does that make sense?
Yeah.
So that's a key component in the reasoning, I would say.
Okay, so
That's the main reason why, right?
yeah, but then, like you said with cosine, like you can't go by the angle.
I didn't say that. I just said that it didn't follow the same rule.
Oh yeah, that's what I mean.
Yeah.
You can't just be like, oh, 44 is bigger, so 44.
Well, it's the opposite logic, one could say. With a larger angle, you're going to have a longer base. Does that make sense?
Yeah.
Yeah. Therefore, for a larger angle, you're going to have a shorter base.
Yeah.
Okay? Because the larger it goes, the skinnier it becomes. Like that
Yeah.
versus this. So for cosine, because it's adjacent over hypotenuse, the larger your angle, the smaller the cosine.
So with ones where you have to deal with the opposite angle, it always goes by the bigger angle with the bigger ratio.
Except if you're talking about something like cosecant, which is hypotenuse over opposite.
Yeah, but if the opposite.
But if the opposite is in the numerator, then yeah, then the fraction is going to go up, right? Yeah. Yeah, I encourage you to do whatever it takes to have it make sense to you. I will do my best, but I can't cater to everyone's personal needs. So we got, this is false. Okay. Next, number 23. Find the equation of a line passing through the origin and making a 30-degree angle with the positive x-axis. You got it. Passes through the origin. Making a 30-degree angle with the positive x-axis. Well, I want the equation of the line, so it's going to be y equals something if I want to use slope-intercept form. All right, my random helper is Jake. Tell me what you know that can help us find this equation.
You could find 2 points on the graph.
I can find 2 points. Okay, what's the easiest one probably?
The origin.
The origin. What does that mean about our line's equation?
It doesn't have a lot. It's y-intercept is 0.
Very good. So I know it's going to be y equals mx, right? Since the yint, which is Yiddish for y-intercept. Thank you for laughing, that was a joke. Is 0.
It was actually
Now I have to find the slope.
Yeah.
How do you think I could find that?
You could find 2 points, but you could probably also do something else.
Totally valid to find 2 points.
Yeah.
And we found one of them. The trick is finding the other one. It probably is going to require this, right?
Yeah, you could probably use 30, 60,
Let's do it. Let's do it. It's one word. Do it. That's neither here nor there. Help me with labeling this.
30, 60, 90.
Okay? Done?
And then you go to 1, 2, 3, 4, 5.
I didn't do it to scale. You can't use that.
Uh,
Use your knowledge of a 30, 60, 90 triangle.
so like X.
Yeah, so where's X?
Cross from 30.
Cross from 30. How about the base?
X root 3.
X root 3. And the hypotenuse?
It is 2x.
Okay. Tell me what you know about slope.
Rise over run.
Very good. So what's the rise here?
X.
And the run?
X root 3.
Okay. Help me simplify that fraction.
Root 3.
It is not root 3.
X root 3.
It is not. So the x's cancel, and what are you left with?
Root 3. So
No.
root 3 over
Root 3 doesn't just jump up into the
Yeah,
numerator.
you can multiply it.
It's still in the denominator. So it's 1 over the square root of 3 before rationalization.
So
Now you can multiply top and bottom by root 3 over 3.
3.
One of the best inventions, the quad color pen. So what do you get when you do that top and bottom thing?
Root 3 over 3.
Okay. That's the slope.
Yeah.
So now we're at our answer.
Y equals
x. Okay? So we're using your knowledge of 30, 60, 90 triangles and your knowledge of lines, combining them to get an answer. I hope so. Any questions on 23? Find the exact value of x in the figure. My random person is Julie. Any idea?
So, you look at the 30-degree angle
Yes.
on the direction triangle to the left,
Yes.
and opposite to that is x.
Yes.
And so that would mean that it's 3 because the hypotenuse is 6, and 6 is 2 times x.
Very good.
Divided by 2.
This is the 2x side. Therefore, x is 3. Keep going.
Opposite to the 60-degree angle is 3 radical 3.
Nice. 3 radical 3. In a 30, 60, 90, the side opposite 60 is always the square root of 3 times the shortest side. Good. Continue.
And then you just get a, because x is just 3 because
No, I disagree that x is 3. You have a 45, 45, 90. Therefore, this is going to be congruent to this. Yep. 3 root 3. Okay? It's a fun little puzzle. A 30, 60, 90 matched up with a 45, 45, 90. Any questions on 24? Yes?
Why wouldn't it be B? Because isn't the 45, 45 each side? Oh, never mind.
If they wanted the hypotenuse
Yeah.
of the 45, 45, 90, it would be B.
Oh, okay.
Because this is 3 root 3 times root 2.
Okay.
Moving on. 25. Find a formula for the area of the figure in terms of S. Random person. Absent. Absent. Darian. Tell me what you know about areas of triangles.
It's 1/2 base times height.
Very good.
So it'd be 1/2 s root 3 times s.
Very good. So, in this case, the height of our triangle is S. The base is going to be root 3 times S, because it's the 30, 60, 90.
So s root 3.
Okay? And then when you simplify this, the S's multiply to be S squared.
Okay, so s squared root 3.
Mm-hmm. Yeah, all over 2. Or root 3 over 2 S squared, which is choice C. Nice. Well done. Any questions on 25?